Hi guys, welcome to my channel. Today lecture is will be on chemical test to distinguish alkana and alkanone. Chemical test to distinguish alkana and alkanone. I'm going to explain oxidation reaction, Fehling solution test, and tolling reagent test. I've explained oxidation of alkana under chemical properties of alkana. Only alkana will oxidize to alkanoic, while alkanone does not undergo oxidation reaction. Then alkana will oxidize to alkanoic in the presence of what? Of acidified K2Cr2O7. So the orange color of potassium chromate, the orange color of potassium dichromate will turn to green solution of what? Of chromium 3 ion. The orange color of potassium dichromate will be oxidized to green color of what? Of chromium 3 ion. So you are still going to write your chemical reaction for that. That is alkana is RCHO in the presence of what? Of your oxidizing agent, oxygen. Then that's in the presence of K2Cl2O7. So it will oxidize to what? To alkanoic acid. Then I've explained that under the chemical properties of alkanoic acid. So the orange color of potassium dichromate when react with alkana will change to what? Will change uh, to green solution of chromium 3 ion. Chromium 3 ion. So it shows that you have to what? You have to add your alkana to water. So your alkana will dissociate in water. That's RCHO. So in an acidic medium with water, the hydrogen ion from water molecule will dissociate in water to form 2H plus. Then the oxygen will now combine with alkana to give you RCOOH. So that is in an acidic medium. At the same time, your oxidizing agent will also decompose. Your oxidizing agent will decompose. That's K2Cr2O7 will decompose to what? To Cr2O7 2 minus plus what? Plus 2K plus. Then this the orange color of this dichromate, of this chromium oxide, the orange color of the chromium oxide, that is Cr2O7 2 minus, will now what? It will reduce to what? The chromium 3 ion. So the chromium is plus 6 here. Plus 6 here is reduced to what? To chromium 3 ion. That's Cr3 plus. 2Cr3 plus. So chromium is 3 plus here, while chromium is what? Plus 6 here. So there's reduction. The reduction of what? Of chromium to chromium 3 ion. So which shows that alkana is a reducing agent. Alkana is a reducing agent, while this chromium will serve as what? As an oxidizing agent during the chemical reaction. You may be asked to write your chemical reaction in an acidic medium, or in what? In a basic medium. If they ask you to write the chemical reaction in an acidic medium, it shows that you are going to apply your what we call redox reaction. Your redox reaction, you are going to balance your redox equation. If you were asked to write your reaction in what? In an acidic medium, you balance your redox equation, which is called redox reaction. Then your chromium, your chromium your dichromate, which is Cr2O7 2 minus, which reduces to 2Cr3 plus. So you are going to write your what? Your redox equation for this one, for this reaction, that is for your dichromate, for your potassium dichromate, and what? And your alkana, which dissociates to what? To alkanoic acid and hydrogen ion. So you write your redox equation for the two reactions. So for this first one, you balance your redox equation. This is half reaction. This is the second half reaction now. So for the first half reaction, you balance your redox equation for the first half reaction. Then for the second half reaction, you balance your redox equation. So our equation is not balanced there for the first reaction. We have two proton here. We have two proton here, so you have to minus 2e minus to balance your equation for the first reaction. So likewise, this one too is not balanced. So you balance your chemical equation. That is Cr2O7 2 minus gives what? 2Cr3 plus. So we are deficient of oxygen at this side when we follow method of what? Of balancing redox equation. So this side is that we have 7 oxygen at this side, but this side is deficient of oxygen. And according to method of balancing redox equation, the side that is deficient of oxygen, we get oxygen from what? From water molecule. So water molecule will be added to balance what? The number of oxygen at this side. So since we have 7 oxygen at this side, so I will balance with what? 7 molecules of water. So from 7 molecules of water, I've gotten my 7 oxygen. So, but something has been added to this side that is not here. There is what? Addition of hydrogen at this side. So 7 times 2, we have 14 hydrogen at this side. So you have to add 14 hydrogen ion to this side to balance your equation. Then, but the number of electron at this side is not equal to the number of electron at this side. So you have to balance your electron at both sides. From this side now, we have minus 2. 14 times 1 is 14. So minus 2 plus 14 will give us plus 12. So we have plus 12 electron here. Plus 3 times 2 is 6, plus 6 at this side. So plus 12 here and plus 6 here. So this is a free molecule. So the number of what? The oxidation number equal to what? 0. So oxidation number for this one is plus 6. Oxidation number at this side is what? Is plus 12. That's minus 2 plus 14 will give us what? Plus 12. So we have to balance at both sides. So we're having more what? Oxidation number at this side than this side. So we minus 6 from this side to balance this side. So therefore, our equation will now be Cr2O7 2 minus plus 14H plus 6E minus. So you subtract 6 electrons from what? From 12 to give you 6. So that we'll be able to have 6 electrons at both sides, equal to 2Cr3 plus 7H2O. So our equation is what? Is balanced now. Then when we compare what we have, don't forget that the number of electrons from the first half reaction must be equal to the number of electrons for the second half reaction. So this is second half reaction. Then this is first half reaction. First half reaction. We call this one first half reaction. Then this is second half reaction. So we have 2 electrons at the first half reaction. Then we have 6 electrons at the second half reaction. So we have to balance the number of electrons at both sides. We have to balance the number of electrons at both sides. So I will multiply the first half reaction by 3 to get 6 electrons. So multiply this side by 3. So my equation will now be 3 times RCHO will give me 3RCHO. 3RCHO. Then 3 times 1 molecule of water will give me 3H2O, equal to 3 times RCOOH will give me 3RCOOH. Then 3 times 2 hydrogen ions will give me 6 hydrogen ions. Then 3 times 2 electrons will give me 6 electrons. So therefore, the number of electrons from the first half reaction, we cancel the number of electrons at the second half reaction. Now, we combine the 2 half reactions together to form our product. So, what we have at the reactant side here plus what we have at the product side here. So, now let's combine what we have here and here together. So, the first thing at the reactant side here is 3RCHO. 3RCHO plus we have 3 water molecules here. So this side we have less water molecule than this side. So we have 7 water molecules here. So we are going to what? Collect the like terms by moving these 3 water molecules to the side where we have 7 water molecules. Then at this side we have 14 electrons. We have 14 hydrogen ions here. At this side we have 6 hydrogen ions. So we are going to move these 6 hydrogen ions to this side. So that will be plus Cr2O7 2 minus, that is the reactant side here, plus 14H plus. Then we move 6H plus to this side, minus 6H plus. Then all reactant side at this side. Then we have to move water to this side now. So to our product side, at the product side we have 3 RCOOH, then plus 3 RCOOH. Then what we have at the product side there, plus 2 Cr3 plus we have 7 molecules of water here, that's 7H2O. Then from the reactant side there, we move 3 molecules of water to the product side, minus 3H2O. So our final product will now be 3RCHO plus Cr2O7 2 minus 14 minus 6 will give us 8H plus, then equal to 3RCOOH plus 2Cr3 plus 7 molecules of water minus 3 molecules of water will give us 4 molecules of water. So this is our chemical reaction in an acidic medium. That is, if you were asked to write your chemical reaction for oxidation of alkanal to alkanoic acid in an acidic medium, this is how you are going to write your chemical reaction for that. So number 2 is reaction with what? Fehling solution. Reaction with Fehling solution. So the next one is number 2. Reaction with Fehling solution. Then the Fehling solution contains copper complex. Copper complex. Then the copper complex is gotten from Fehling solution A, because Fehling solution the Fehling solution is a mixture of Fehling solution A and Fehling solution B. Then Fehling solution A it contains what? Copper 2 tetraoxosulfate 6. So the copper complex is gotten from that copper 2 tetraoxosulfate 6. So the blue, when alkanal is added to Fehling solution, a brick red precipitate of copper 1 oxide will be formed. So the chemical reaction for that is RCHO plus copper complex. Then the copper complex is gotten from copper 2 tetraoxosulfate 6. So the copper complex will serve as an oxidizing agent that will add oxygen to your alkanal to give you RCOOH plus what? Plus copper 1 oxide. So it will be reduced to copper 1 oxide. So number 3 is reaction with what? Tolling reagents. Reaction with tolling reagents. Tolling's reagents. Then tolling reagent is a constituent of sodium hydroxide, silver triazonitrate 5, and sodium. The sodium hydroxide, then silver triazonitrate 5, and ammonia. Then we can also call it ammoniaca silver triazonitrate 5. We can call it ammoniaca silver triazonitrate 5. That is your toluene reagent. So we are going to add what? Our silver complex. Addition of silver complex. So when toluene reagent is added to alkanal, a silver metal will be deposited. On the wall of the test tube. So when an alkanal reacts with toluene reagent, so a silver metal will be deposited on the wall of the test tube. So the chemical reaction for that is reaction between an alkanal CHO and what? And silver complex. So the silver complex will serve as an oxidizing agent that will what? That will add oxygen to your alkanal to give you RCOOH. And the silver metal, which is Ag, will be what? Will be deposited on the wall of the test tube. So will be deposited on the wall of the test tube. So that's all about chemical tests to distinguish alkanal and alkanone. Remember to subscribe to Royal Learning Channel. Share this video with your friends and comment. Bye.